This is section 3.5, specifically a section that's going to work with right triangle trigonometry within the context of application problems. We are going to start, though, first with these three problems, which actually relate a little bit more to section 3.4, inverse trig functions. Just a reminder of a few things before we jump into this problem. Please don't forget, our signs are always going to be opposite over hypotenuse. The ratio of the sides opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse, and the tangent is opposite over adjacent. So in this particular problem, we are being asked to find the angle theta, okay? But notice right now, 90 degrees was given to us in this angle, but we have two unknowns right now, so we can't necessarily figure out what theta is just by saying 90 plus theta plus another angle equals 180. It doesn't help us at all. All we know is that these two angles will end up adding up to 90, but we don't know what that combination is. So that property or characteristic that we used in geometry is of no use to us. But what they did give us is they gave us the length of two different sides of our right triangle. So we're going to use those to help us determine what this angle theta is. So since we are standing at angle theta, I'm going to highlight it to make it a point that that's where we're standing. That's our angle of reference, okay? So with respect to this angle, we look towards the 4, and we label that either with adjacent, opposite, or hypotenuse. Well, this side is the adjacent side to us. And if we look to the other giving angle, that angle is given to us is the hypotenuse. So the AH combination, the ratio, is going to give us a cosine equation. So to set up your cosine equation, you write cosine of theta, which is the angle where we're standing. You always give the reference of your angle, equals AA over H. Well, the cosine of my angle in this case is going to be 9 over 4. Oh my goodness, nope, 4 over 9. So if I want to isolate my theta, I need to take the inverse of the ratio 4/9, or the arc cosine of 4/9. So you will plug that into the calculator, take the cosine inverse, and if you round it to 1 decimal place, it will be 63.6 degrees. Now you want to make sure that your calculator, check the mode of your calculator, and make sure that you set it to degree mode. Okay, make sure it's in degree mode, the units that you want your angles to be measured in, and in this case, degree. So let's do that again with this next image. So we highlight where we're standing and look towards the angle, the side lengths that were given to us, and we label them. Well, the side length 8, that's going to be our adjacent side, and the 10 is across, so it's an opposite side. That ratio is the combination for tangent function. So we write our equation, tan theta is opposite over adjacent. So let's substitute what we have. So the tangent of theta is going to be the opposite length over the adjacent length. And in order to isolate theta, I have to take the tan inverse of my ratio. And when you type that out into your calculator and round it to the nearest tenth of a degree, you will get or let's do 100th of degree this time. 51.34 degrees, okay? Then you can put the squiggly line, or I'll just put equals to be consistent. Okay. So I want you to pause your video now, and I want you to try the last one on your own, okay? And then unpause and see if you did the same thing as I did. Okay, so you should be back by now, and you would have been labeling your sides as follows. So this side is across from me, so I'm going to put it as opposite. And this length here is across from the 90 degrees, so I know it's my hypotenuse. So the formula for sine theta is opposite over hypotenuse, and I substitute what I have. Well, the sine, I don't substitute theta because I don't have the angle. Opposite over 12, which is my hypotenuse. I need to solve for my angle. And so I take the sine inverse of the ratio. So the angle will end up being, if you round to the 100th degree again, will be 24.62. And if in case you're asking, what do I know when I'm going to round to what, it will be stipulated in the problem. Okay, so that's how you find angle measurements of right triangles if they give you two sides. Okay, and as you know, if you figure out one angle already, you can easily find the third one because you have the 90-degree angle, and now you have the 63.6%, for example. You can add those two and subtract it from 180 to find the third angle. Anyhow, let's go on to the next page. So you're going to have some instances where they talk about angle of elevation and angle of depression. So here's what I mean by that visually, okay? So for angle of elevation, it's when if you start from a horizontal, okay, and that it doesn't look too horizontal, does it? Let's try that again. See if I can get that to be straighter. Okay, that's the best I can do. So let's say we take that line, and there is, let me see if I can get another color on top of it. Okay, so there's this other one right here. If you start at a horizontal and then your angle increases upwards, okay, so it started here and it increased, okay. The increasing movement caused the angle to open, okay. This is your angle of elevation, okay. So your line of sight moved from the horizontal into a more upward angle. So it's as if you were standing here, okay, and you spotted, I don't know, an airplane flying overhead. This is going to be very, okay. Your upward eye movement caused your angle of elevation to increase. But what if the reverse is happening? So let's say instead, let's take that very same airplane. Okay, the horizontal, this time of the airplane, is like so. Let's try drawing again here. My goodness, this is not a good airplane. Okay, it's my best attempt at drawing an airplane. Okay, and the pilot instead now spots something in the distance, okay? But it causes his eyesight to project downward to the ground, okay? So what happened in this case, if you notice, his eyesight or his line of sight changed from the horizontal downward. So now this is his line of sight, or her line of sight. And so this is now instead an angle of depression. Okay? So those are two different types of things that are happening. Say he saw some beautiful trees and was admiring them. Okay? So these are the two different scenarios that you will have within your application problems. So let's practice 3 problems here so that you can then practice on your own. So example 2, here's our first application problem. A giant redwood tree casts a shadow of 532 feet long. Find the height of the tree if the angle of elevation of the sun is 25.7 degrees. So here you can just use a little bit of your creativity to come up with an image. Now, within these images or these scenarios, there's always going to be a right triangle trapped in it, okay? So here's my very poor attempt of drawing a tree, okay? And we just established that this tree is going to have a shadow created by it, okay? So on the ground somewhere, this shadow is, so here's this ground, this shadow is being created. So let's create a shadow here. So it has a shadow. So let's say that's the shadow that's being created by this tree. Okay, now, what else did they give us? They told us that this shadow was 532 feet long. So we need to label that. 532 feet long. They also said that the height of the tree is what we're looking for. Find the height of the tree. So let's go ahead and create some sort of image that tells us what the height of the tree looks like. So here's the height of the tree. Since that's what we're looking for, we will label it H. Make that really dark there so you can see. So we're looking for H. So hopefully at this point, you're starting to see where I'm kind of going with this. Do you notice that there's a bit of a right triangle popping out into your image? Okay, so it's not the straightest of lines, but you get my point. So they're wanting you to kind of pull that right triangle out to help you figure out what it is that we're looking for. They told us that the angle of elevation of the sun is 25.7. So here's the thing. You have 2 angles that you get to choose from. The angle is either going to be this one right here, or it's going to be this one right here. But the question is, which one of those is an angle of elevation, okay? Which one did your line of sight go up? So your angle of elevation is actually going to be from this angle, 25.7 degrees. Oops. Oh, I can't write the degree symbol for some reason. There we go. Okay, if you notice, your eyesight is going upwards. So you could just think of somebody standing here, for example, and they're looking up at the tree, okay? So their eyesight will go up to see the height of the tree. So once you have established what your right triangle looks like, notice now that you can label the sides based on what sides are given or what you're looking for. So this is my angle where I stand at, just like we did at the beginning of class with that other problem, right? And I see that my H is going to be my opposite side. And I notice that the given length of the shadow, that's going to end up being my adjacent side. So opposite and adjacent tells me to write out a tangent function. So the tangent of theta is going to be opposite over adjacent. I'm going to substitute what I know. Well, tangent. Do I know theta? Well, this time I do. So I'm going to substitute theta with 25.7 degrees. Do I know what my opposite side is? No, but I know I label it H. And my adjacent side, I do know it. So 532. Since I am solving for h, okay, I need to isolate this variable. That means this number needs to go. So what do I do to both sides? Well, 532 is dividing, so I need to multiply by 532 on both sides, and that will end up looking like this. So now I have 532 times the tangent of 25.7 degrees equals to h. Okay, because the 532 canceled on the other side. Once I type that into my calculator, again, make sure that your calculator is set to degree mode. You'll end up at 256.03, and don't forget your units, feet. So here is your final answer as far as the height of the tree. So what I'd like you to do now is on this next problem, try and figure it out on your own. Pause and draw this picture out, this triangle out, and label, and see how far you can go with it. And then come back to me and we'll work it out together. Okay, so you're back. Let's draw this picture. So here we have the top of a 200-foot lighthouse, and the angle of depression to a ship is in the ocean at 23 degrees. How far is the ship from the base of the lighthouse? Okay, so again, poor attempt to draw a lighthouse. I should have gone and found an image, but here we go. Let me do this. I'm gonna make our lighthouse like a dark purple. So here's a lighthouse right here. And let's label it lighthouse. And this lighthouse is sitting on the coast of the ocean. And let's have some really nice blue water. I'm being quite creative. And out in the deep blue sea, we see that there is a ship. Okay, so there's a ship out here somewhere. So let's call it a ship. And what has happened is that we have spotted this ship out there, okay, from the top of the lighthouse. Okay, so we have spotted it out there. And they have told us that the angle of depression of, viewing this ship is going to be, 23 degrees. So angle of depression, so if I'm standing up here somewhere and I am looking straight ahead, right? That's your normal visual. They're telling us that the angle of depression is 23 degrees. Was it 23? Yeah, 23. Now, they also told us that it was 200 feet tall. So let's also put that. So here you have this image again pop out. And you notice there's our 90-degree right triangle. And they're telling us to find the distance the ship is from the base of the lighthouse. So what we're trying to find out is, let me see if I can get like a red. There we go. That's kind of close enough. The base of the ship to the, hold on, you can barely see that. Let's do it from here. It's not working with me. Okay, so right here, that little red line, that's what we're trying to figure out. And we don't know what that is, so we're going to label it X. Okay, that's what we're looking for. So the question is, where is the angle that I need to stand at? Okay, that's always the important thing. So right here, this is our triangle right here, okay? So you're focusing on that. And notice that none of the angles are given to us. We do not know what this angle is right here, and we don't know what this angle is right here. But they did give us the 23 degrees. So hopefully what you're doing is you're remembering from geometry. Notice that this here is a 90-degree angle, okay? Let me do that a little bit better. This right here is a 90-degree angle. So the sum of those two angles have to be 90 degrees. So to find this angle right here, all we needed to do is 90 minus 23 to get 67 degrees. So now we are able to establish that we are standing right here, and we are able to label the sides that we need to label. So the X side here, turns out, will be our opposite side, and the lighthouse side with the 200 feet is going to be our adjacent side. So again, it just so happens that two of the problems that we chose to practice with you guys turn out to be tangent. So please don't think this is the case every single time. So you write out your equation and you substitute with what you know. So tangent, my angle is 67 degrees because it's the inside angle, not the angle of depression. Equals, my opposite side is length x, and my adjacent side is length 200. And again, you are going to need to multiply by 200 on both sides to isolate your x. So you're going to end up with 200 tangent of 67 degrees in order to isolate your x. So what is your x? Rounded to the nearest hundredth. So that means 2 decimal places will end up being 471.17 feet is how far that ship is from the coastline or from the lighthouse. So here are 2 examples where you guys had to find a distance, either a height or a distance. Now look what happens when instead you're being asked to find an angle, and this is our last problem. So let's read this together. A 40-foot ladder leans against a building. If the base of the ladder is 6 feet from the base of the building, what is the angle formed by the ladder and the building? Okay, so let's draw a little house here, okay? And this house has a wall. Okay, so establish that as the wall. So right here, this is our building. And on this, against this building, you have a ladder that's leaning against it. Okay, let's make this be our ground here. So we have the ground here. Okay, so here is this ladder. Let's make it look, no, that didn't work out. My goodness, it won't let me do it. Let's see, there we go. It doesn't like that it's so close. All right, let's do it freehand here. I insist that I will win. So there we go. It's not a very good straight line, but you get it. So here is my ladder, and this ladder is a 40-foot ladder. So let's label it 40 feet. And they told us that this 40-foot ladder is leaning against the building and that the base of the ladder is 6 feet from the base of the building. So let's label that. So this is 6 feet right here. Okay, let's scoot it over a little bit more. Okay, so what is the angle formed by the ladder and the building? So again, here is our 90 degrees, okay? And so you guys have to decide which between these two right here are going to be the angle you are going to stand at, okay? Well, since they asked you for the angle formed by the ladder and the building, that means your theta has to be the one up here, okay? Because that's the only one that is formed by the building, which is this part, and the ladder, which is this part. So if it had been the other one, they would have said the ladder and the ground. So now that we have established that, we can go label our sides, because once you know where you're standing, you label your sides. That's why I told you guys at the beginning, let's review, your SOHCAHTOA, because throughout these, you always need to make sure which of the three trig functions are you going to use. So if I'm standing here at the theta, okay, I'm always highlighting for you guys where we're standing. We notice that the 40 is going to be our hypotenuse length because it's across from the 90. And then the 6 feet is across from our theta, so that's going to be the opposite length. That combination is going to be our sine function. So sine function, so we go sine of theta equals opposite over hypotenuse. Sine of theta, again, because we don't know what theta is, our opposite is 6, our hypotenuse is 40. What do I do when I am looking for an angle? Remember I told you guys, angle means always look for the inverse of your trig. So theta is the sine inverse of your ratio. And when you put that in your calculator and round it to the nearest hundredth, you are going to get 8.63 degrees. So the angle between the ladder and the building is 8.63. Hope that helps. Thanks for watching.